I don't know where it's going. All right, 13.1, use trigonometry. I'm just going to write trig with right triangles. All right, so evaluate the 6 trig functions of the angle theta. So they give us a triangle that looks like this.
Yep, here we go. Now we get to draw.
It's a right triangle. It's 2 straight lines and then a diagonal connecting them. All right, in this particular one, they give us this angle over here. This side is 8 and this side is 5. So back from geometry, if all I wanted you to do was find the third side, what would you tell me to do?
I know. You have to A squared plus B squared equals C squared.
Yes.
Oh, I was not really gonna say that.
I don't know what you were going to say
I
then.
was gonna do one of the weird, like, sine cone things.
Well, that is ultimately what we're doing, but you need to have the other side to do that, so. All right, so I probably will not write the Pythagorean theorem every time. I'm going to assume that you know that. Now, the side that I'm trying to find is C, in this case, the hypotenuse. So I'm going to have 8 squared plus 5 squared, and I'm going to go ahead and just take the square root of that equals C. So that's the square root of, what, 64 plus 25. So the square root of 89 is
12. It's not 12.
That's not.
Oh. Watch it be
12 and a half.
oh, I know what the problem is. I copied the problem wrong.
Oh.
This is supposed to be a 3. I was like, that's a weird number. Not gonna say it's still not gonna be a weird number, but that wasn't the right number. Just change it really quick to a 3 instead. I was like, that's not the number that matches up with what I have. All right, so
Wow.
I forgot. We don't actually put these in our calculator. We leave them in radicals. So this is the square root of 73. So this side is the square root of 73. We don't write stuff as decimals. We write it as radicals. If the radicals can be reduced, okay, to get you ready for pre-cal next year, you should reduce them, okay? As far as, like, taking stuff out if you can. Now, if you don't, I'm not necessarily going to mark it wrong, but as far as getting you ready, because in pre-cal you have to simplify them as much as possible, okay? Some years I'm like, yeah, don't worry about it, but now that pre-cal's AP and, like, somebody else cares at the end about it, and I would assume a lot of you will probably take pre-cal, if not all of you, I would rather just get you ready for that now. So, anyways, so then what I do is I come over here and I set up, I've got to solve for all 6 trig functions of theta, and I want them done in this order. So going down, sine, cosine, then tangent. And then on the other side, cosecant of theta, secant of theta, and cotangent of theta. Okay, so they need to be in this order. So sine is opposite over hypotenuse, so that's going to be 3 over the square root of 73. Now, I cannot leave a radical on the bottom. What do I need to do?
Oh, plus 73 on top.
I need to rationalize it by multiplying top and bottom by the square root of 73. When I do that, on top I get 3 root 73 over 73.
Is there a reason why it can't be on the bottom?
It's just a rule that we can't leave radicals on the
It's not
bottom.
that person.
Oh my gosh.
Yeah. Somebody one year decided that we can't have radicals on the bottom, and we need to rationalize them. But I will tell you, the reason that I initially write it this way, because truth be told, I can go straight to here without even time to think about it. And as we do more and more of these, probably by the end of this section, you're going to be like, I can go straight there. But when I do cosecant, so normally I won't go in this order. Normally I go down and then I do these. But when you do cosecant, that's just 1 over sine. It's just flipped. Okay, it just flips the things. It's hypotenuse over opposite. So cosecant will be the square root of 73 over 3. if I had to flip this, then I'm going to be rationalizing again and reducing, and it's just a pain. So I use the original when I comes to that. And like as far as like normally, obviously we like box our answers and all of that. You don't need to go in here and like box each individual thing. Like just your answer like as a whole, this is your answer here. So even though you've like rationalized it, obviously I'm looking for your rationalized answer, but there's not so much here that I can't find that. Okay, that's why we set it up this way. So it's nice and easy for me to see everything. All right, cosine is adjacent over hypotenuse. So adjacent's the one that's touching it over the hypotenuse here. So 8 over the square root of 73.
How do you know which one's adjacent again?
It's the one that's beside it,
Beside what?
the angle,
Oh, okay, the one
that's touching it.
Okay.
So then rationalize, but you're multiplying by the square root of 73 top and bottom. So I have 8 square root of 73 over 73. And for this one, I'll just go ahead and do them. I'll do secant now. So secant is 1 over cosine, so it's flipped. It's hypotenuse over adjacent, so it's going to be the square root of 73 over 8. And then lastly, the tangent cotangent one. Tangent is opposite over adjacent, so SOHCAHTOA, in case you don't remember that.
3 over 8.
So 3 over 8. This one, obviously, no radicals, nothing to rationalize. And then cotangent, we flip that, would give us 8 over 3.
So
Okay, this
is there,
doesn't feel that bad.
is there a SOHCAHTOA for the, like, new neighbors? Like
For
the,
these?
Yeah.
No, it just flipped.
Okay, like Cho-Cha.
I mean, you can make one up. And there's like acronyms to remember SOHCAHTOA. Like I thought that just kind of like made sense. And then one day I was like saying something about whatever I was teaching at the time, like in trig to my father-in-law, and he like rambled off this thing about a horse that apparently is how he remembered SOHCAHTOA. And I was like, what? And then I looked it up, and there's like a ton of little acronyms to help you remember SOHCAHTOA. I feel like that's the easy one, but I mean, if you want to go memorize something else, that's fine too.
I'm pretty sure your mom told us that SOHCAHTOA was like an Indian chief.
Yeah. She had this whole, like, backstory that she
There are. So, like, there's that one, and then there's, like I said, like, the one about the horse. You could look them all up. It's kind of crazy, the ones that people have come up with. It's kind of like never eat soggy waffles.
Right.
Or the one about my great-aunt Sally or whatever,
Oh, yeah.
you know.
Oh.
My very eager mother and all that stuff. You know, all those things. People have come up with that for SOHCAHTOA. I think SOHCAHTOA is enough of an acronym itself that I don't need anything else. If you do, just Google it and find your favorite one and memorize it.
Cool.
Anyways, that's your answer. As far as I'm concerned, when you do something like this, you don't really need to box these because it should be pretty obvious what your answer is, but I'm just letting you know. All right, number 8. So another one where they give us the triangle.
I was gonna say that's a square. So when they're giving the examples like this, and it's a really tiny triangle, like or like a thin triangle like that,
Look
can
at
I
mine.
just draw a regular triangle?
It doesn't matter what the triangle looks like. Yeah.
It looks like a bird beak.
Like when we get to later ones, I will always draw my triangle looking like this. These are triangles that were given to me. But on the quiz, I'm not giving you the triangle. You're going to draw it yourself. Some people draw them upside down and backwards and whatever. I don't care. You pick your favorite direction to draw your triangle, and as long as you set it up correctly, I don't care.
It just has to look like a triangle.
Yeah. Sometimes I have to draw a triangle multiple ways.
I got
to get
news
my
for you.
answer.
I'm not really looking at your triangle.
You don't care that we know how to draw our shapes?
Not really.
Should be extra points.
My triangle.
All right, then what they give us, let's see if I can actually read the problem correctly this time. 8 is down here, and this is 2 root 17. Okay, so they have already, reduced that one, whatever you want to call it, for us. But I'm still missing a side, obviously. And I need to find this other side. So, this time I already have C, and it doesn't matter if you call this A or B. the sides being A or B. Doesn't matter, they're interchangeable. So I have, when I do the Pythagorean theorem and I'm solving for one of the sides that's not the hypotenuse, I go straight to that modified formula, right? Because we have a squared plus b squared equals c squared. So I typically will just say a squared equals c squared minus b squared. Okay, I just go straight there. It's just a different version. If you want to set it up the original way and do all the extra steps, that's fine. But I will do a squared equals c squared minus b squared. C is always the hypotenuse. It's always the longest side. So a is the square root of 2 root 17 squared minus 8 squared so this is was that 17 times 4? No.
4.
2 squared is 4. So this is the square root of 68 minus 64, which is what?
4. 2. Well,
2.
Yeah.
Trying to avoid writing as much as possible. So I try to get there as quick as possible also. All right, so this side is 2.
Nice.
So obviously this triangle is drawn opposite of the one we previously did, so just pay attention to what angle we're solving it for. Also, I think y'all know this, but the class last year absolutely drove me insane. This is sine, not sin. This is cosine. This is tangent, cosecant, secant, and cotangent. And this thing is called theta, not O.
No, theta.
I finally had to tell them if they continued doing that, I was going to start taking points off. Because they would start saying things that were not it. They'd be like, sin 0 or sin O. And I was like, no, we're not doing that. It was very annoying. Anyways, making sure that we know what these things stand for. That's what happens when you don't listen to the notes.
yeah.
All right. Sine of theta would be what?
2 over 2 root 17.
I can't read my notes.
Yep. 2 over 2 root 17. Now, the 2's we already know can cancel top and bottom. Okay, and then I have the square root of 17 down here, so what do I need to do?
Multiply the thingy up on top of the thing.
Yep.
You get it.
Thanks, Mason.
You're welcome.
17.
So square root of 17 over 17.
Yeah.
Because yeah, the two's canceled.
Yeah. Absolutely.
I knew
All right.
that, but like.
All right, I always go down on the last one just because I was showing you stuff. I was doing them side to side, but I always do sine and cosine and tangent. So anyways, cosine would be what?
8 over 2 root 17.
Yep.
That can be down to 4
Yep.
over square root of 17.
So the 2 and the 8 reduce, so I get 4 on top over the square root of 17, but I've got to rationalize that, so what do I get when I do that? 4 root 17 over 17.
Ow, my wrist.
And then tangent,
I don't know.
3 over 8.
What?
2 over
2.
2 over 8.
I'm looking at the wrong
1/4.
column, y'all.
Hey, clearly I looked at something wrong earlier. Now-
I was still looking at number 4, and I was like, these are not the same numbers.
Now, one thing I'm going to tell you when you're doing something like the tangent one that we just did, okay, obviously all of these had things that reduced, but specifically with tangent, okay, if in your head you're like, okay, well, I know 2 over 8 is 1 over 4, you don't need to write the 2 over 8. If you want to, you can, but you can go straight to the reduced number, okay? Some years I also make the classes write that we're multiplying by the root 17 over root 17. I'm not going to make you write that, okay?
Thank you.
But if you need to help you remember, then obviously you can. Okay, now, when I go to do this other column over here, cosecant, we take whatever value we have for sine and flip it. I would use the original since I had to rationalize. But I already know that I had to cancel the 2's. Okay? So as far as I'm concerned, I have 1 over the square root of 17 that I'm flipping. Okay? So what would cosecant be?
1 over the
Square root of 7.
Just the square root of 17. Now, if you flip this final thing, all that's going to end up happening is you're rationalizing and reducing, and you're going to be like, why did I not just use the original? Some people like to not write the original and go straight to the rationalized over here, and then they end up having to still undo it over here. I don't care. Whatever works for you, works for you. I used to try to like micromanage that, and it's too much. Whatever way you want to do it, you do it as long as you get the right answer. I don't care. All right, so secant, I flip cosine. So as far as I'm concerned, this is 4 over the square root of 17. So what would secant be?
17 over the 4.
Square root of 17.
Oh my goodness.
Square root of 17 over 4. Now, cotangent.
4.
Yep.
Whoa.
I knew that when I waited. Like,
Good
So
job.
when we
He was like waiting. He was like, when's she going to say it? When's she going to do it?
when on the cosine, when originally it was 8 over the 2 square root of 17, why wouldn't we just write 17 over, never mind. I was gonna ask why didn't we write square root of 17 over 4, but we did. I just got confused. I'm not confused anymore.
Okay.
I think Shepard's very
So
Daniel looks
Any
confused.
triangle. Well, I'm not confused. I just realized something, and I was like, oh.
Okay.
So a triangle where the top one is root 17, the one on the left is 1, and the one on the bottom is 4, will have those exact same values. Because like the angle, like on the thing, always is those sines and cosines and tangents, right?
I think I'm tracking with you, but I'm not 100%
What I mean is
sure.
like as theta like.
Yeah.
Wait. As theta gets like bigger.
It's the weirdest.
Theta's an angle.
Yeah.
Theta's an angle that we don't know. We could find it, but that's not this section.
Okay. Wait.
That was geometry.
Okay. I'm gonna have to think about this. So.
You got it.
I believe in you, Daniel.
No, because I remember there being like a wave. So like.
Huh?
That's graphs.
Yeah. So if you like graphed it as theta like gets bigger, then the
No.
They have to be like proportional.
yeah.
Yes.
That's what I mean.
Yes.
So it's like orderly.
Basically, yes.
it was already on there.
What?
Okay, we're going to do something that don't have a triangle given to you now. So 10 is the cosine of theta equals 5 over 8. Okay, and basically they want us to find the other 5. Now, when you do this, I still want your answer presented like this. Okay, cosine just happens to be given to you. So you don't have to find that one. We automatically know secant because I know cosine. Okay, but what I'm going to do is I'm going to set up my triangle. So I always draw my triangles facing like this. It is totally up to you how you want to draw your triangle, but I always do it this way. No. It has to be a triangle.
This is trig. Wow.
And this is always my theta.
Do they have a trig for squares?
Trigonometry.
Is there like, so we have triangles, but is
Well,
there
triangles, 2 triangles make a square.
Trigonometry.
Oh.
Wow.
I think we learned that in like 3rd grade, Shepard.
Oh, I wasn't here in
Probably.
3rd grade, Charlotte. Oh, no,
All
it
right,
was
so
3rd grade.
cosine is adjacent over hypotenuse, so that means that 5 goes here, if you draw your triangle the same way I do, and 8 goes here.
Yeah.
Some people go real crazy and they draw their theta up here. I wouldn't do that. Not wrong, I just think it gets confusing. I see too many people get the problems wrong. But it's up to you.
Wait, so it's the same?
Mason picks the confusing way.
No? I literally have done it the exact
You'll get the same answer either way.
So then that does,
But how is
so
moving the theta?
theta can go there and at the top?
It just can't go on the right angle.
So does that mean that
The only place theta can't go is right here.
So does that mean those two angles are
Is there
equal?
other people get the
If
answer?
they
No.
That's
My triangle wouldn't be proportional if I did it that way. It still may not be proportional because I don't know what the third side is yet.
Wait, but in the first one, number 4, wasn't theta in the right angle? Maybe I
No,
drew
sorry,
my
you
triangle
drew it wrong.
No, it was over here.
Okay.
This was my right angle. And then this was my right
We
angle.
have it in the right angle if we know it's 90 already.
It wasn't on purpose. It's just the way my triangle turned out.
You made your triangle.
All right, so I need to find this other side. So again, I'll use this manipulated formula. So A equals the square root of, and I skip as many steps as possible when I get to this point. I will go ahead and square this in my head and write 64 minus 25. And then go to whatever that ends up being, which is
29. No.
39.
39.
39.
Yeah, I'm slow.
I wanted to do it.
so the square root of 39. Can that be broken down any farther?
Yeah, but we don't need
No,
to.
it can't.
Can it?
It
Yes,
can't.
3 times 13.
3 and 13.
Well, both of those are prime numbers, so
Yeah.
can't go any
Yeah,
farther.
that's
So
what I'm saying.
negative on that. But we always want to think about that. Okay, when we're doing these. So this is the square root of 39. So now I set up my 6 trig functions. I already know cosine, so I'm going to go ahead and write that one in.
Yeah, I still like hear sin O in my head when I'm writing it.
Just don't say it out loud.
Or you get points off.
I don't like that.
It will irk me so bad.
That's what I do when I like.
Koto.
Koto, where?
Koso, Seko, Koto,
Koto.
Yeah, they'd be like, Secco, whatever. And I was like,
That's
I was like twitching. I was like, can you please stop? I'd be like, if that's what you think in your head, that's fine, but don't say it out loud.
That's what I was thinking the entire time I wrote the notes.
Were you listening to the notes?
Yes.
No.
As I said, what happens when you don't listen to them? All
You
right,
don't know
so
what quiz is.
sine of theta is what?
Square root of
8 over
39 over 8.
Yep, square root of 39 over 8, opposite over hypotenuse.
Yeah, we don't.
Tangent.
How'd you do that?
Hi, Zach.
Welcome back.
Hi,
We're
Zach.
learning funny words like not Koto
Hey, Zach.
because we're not allowed to say that.
Read those words up there.
Read them. Read the red words. You
Do
dummy.
you know the right way to say them?
Sign.
Wait, what is it?
Cosine.
What about what's the O?
These 3 you should have learned in geometry.
He said the O.
I sure hope they did.
He said omega.
Where'd you find that?
Omega's the
Close, theta. Okay, what was tangent?
Square root of 39 over 5.
Square root of 39 over 5. All right, cosecant.
I remember this.
8 over 39 squared. I mean square rooted.
So 8 over the square root of 39, which is...
8 squared 39 over 39.
Now, if you want, and you can do this, in your head, you could automatically have gone to say, okay, well, I know I'm flipping this, and I can rationalize it, so it's going to be 8 root 39 over 39. You can go straight there. I'm saying it again, if you can, okay? If you need to write it flipped and then rationalize it, that is fine. I will write them flipped, then rationalize for the sake of what we're doing. But, like, when I make a test key, I'm just going to write them rationalized. So, all right, secant, the easy one.
8 over 5.
Ryan's got those ones down.
Those are my favorites.
Yeah, because it's just
All
two
right,
numbers.
cotangent.
5 square root of 39 over 39.
Yep, so it's 5 root 39 over 39, but I'm going to write it flipped just so that we have it if we look back. It'd be 5 over the square root of 39, and we rationalize.
Oh, it's like Sokotoa. I remember that.
Yeah.
Yeah,
Yes.
we were talking about this.
Horses
He wasn't in
It's
here.
a conversation, Zach.
and Indian guys. I don't think I missed out on much.
No.
You missed out, not quite anything, actually.
I didn't hear it.
Well, you won't be saying that.
Oh.
It's just smart.
14. Cotangent of theta equals 6 over 11.
Cot. Don't say that.
Don't.
Cotangent.
Koto.
I told them earlier that I had the class last year decided they were going to shorten everything, so they called it Sin O. And I was so annoyed, and I started being like, I'm going to take points off if y'all don't stop.
Sin 0 times.
All right, come back. I'm going to set up my triangle. Whoa, that's going to be a weird one. Okay,
Whoa.
that's crooked. It's going to bother me.
I don't think your magic's working anymore.
Oh.
Whoa.
That's a straight.
Way straight, but it was just.
I don't like how the triangles are facing the wrong
I'm
way.
gonna start on 14.
Well, you can face yours the other way.
Mm.
All right, now cotangent is not one that we just know necessarily. So what may be helpful for you is to go ahead and set up your little table.
My problem is I'm writing my O's like the theta, so
Wait.
I don't know.
Yeah.
Sometimes I find my O's with a line through the middle, and I'm like,
Yeah, I've never done that before, and now it's just like that.
well, because I like do an O and just put a line through it to make my theta. Some people like actually make the O and then put the line through it, which is like not that different. But I just do like one fluid motion.
Whoa. Wait,
Yeah.
what?
My O is not.
That's
fancy
how I write my
pinky up
cursive
letter.
O's. So.
What?
My
That's
O
so
is
cool.
not no fancy pinky up letter.
Okay, cotangent of theta is 6/11. I know that. That's what they gave me. What does that mean tangent is?
11/6.
11/6. So you probably can just set your triangle by knowing that cotangent is 6/11. But since it's not one you deal with often, I have a feeling you're going to put things in the wrong place. So using it as tangent is probably easier. So tangent is opposite over adjacent. So that means that 11 goes here and 6 goes here.
I totally wrote that.
What does that mean? The
That
top
means the
right
number
Costco.
right there.
What?
What is COCOC?
It's CSC, which is cosecant.
Oh.
Remember
He
that
must
one?
not have listened to the notes either.
No, I did.
No,
I
you-
had like my AirPods in. I thought that
Listening to this or something else?
It was both. It was really sped up.
He put it down 2 times.
All right, so I need to find the other side. Obviously, in this case, I am finding the hypotenuse, so I can just do C is the square root of 36 plus 121.
That's 157.
It's a square root.
Now, can we break that down?
Yes. 13 and
6. No.
13.
I think so.
Imagine if I'm right.
I don't think 13.
I don't think there's-
Definitely not 13.
Oh, we get to play against Norfolk.
12.5.
Wait.
What?
Richmond.
Oh, it is.
We don't
Richmond.
do that.
So we're going to Richmond instead of Norfolk?
Bro, we're playing. The name of the school is Richmond
It's
Christian.
in Chesterfield.
What is Chesterfield?
I literally told you.
Oh, well, that's in Rush. You said like Chelsea way or
No,
something.
I said Chester.
No, you did not.
All right, I don't think this one breaks down. I can't quickly find anything that does, so just leave it. So the square root of 157.
Thank you.
All right, sine of theta is what?
11 over 1 square root of 157.
Yep. Rationalizes to 11 root 157 over 157.
So are we gonna end up doing things with these numbers that we're finding?
Chelsea Field.
Yeah, it all kind of builds on each other.
Okay.
Like Lego.
Because I could just do this for like all of trigonometry and
Yeah, I wish it was that easy. All right, cosine theta.
6 over square root of 157.
Just take it. You just take it.
Which gives me 6 root 157 over 157. Y'all must be ready for a quiz because there's an awful lot of talking going on. That's not answering my questions. All right, cosecant is what?
Square root 57 over 11.
Square root of 157 over
I
11.
meant to say the 1.
Yeah, that's what I figured. I was like, it kind of came out fast. Maybe you did say it and
I
it just
didn't.
wasn't giving you the benefit of the doubt. Secant
Square root of
Square root of 157 over 6.
Good job, Ryan.
Yep.
No, his favorite one was
My favorite one is the one without
His
the
favorite ones are
verses.
the ones that don't have the square roots in them.
it's too long to say.
All right. Find the exact values of x and y.
That sounds very difficult.
There is
Why
no
can't we just find the
That's a
regular
different
values?
thing.
We just found
Why
A, B,
can't we
and C.
just leave X and Y?
What about
Why do
A,
they?
B, and
Yeah.
C?
Why do we have to find things that like aren't real?
This is real.
It's on the board.
The
triangle,
Wait, I thought we do the triangles differently.
Oh, 18 new problem.
Oh, wait.
I'm giving it to you as they give it to you in the book.
Oh no.
This is what they give us, and they want us to find x and y.
And then a thingy, and then.
Say it one more time.
45, 45.
It's a special type of triangle, which is a 45, 45, 90. Most people don't recognize that. I'm glad you did.
I did too. I just say
That
no.
wasn't ingrained in our
That means
heads
the
last
legs are the
year.
Yeah,
same.
your mom made
That's
us
good, because
memorize
most
that.
classes come back and they're like, huh?
Does that
I'm
not
like,
mean
how
the
many degrees are in a triangle? And then they like have
180.
no idea.
180 because in a square
Oh.
it's different.
Makes me cringe.
And then
You
X-
said there was 3
Never mind,
degrees.
no.
Isn't x equal to y then in this situation?
Correct.
And then the one is like root 2.
Chelsea.
So in general, our 45, 45, 90, which I'm going to, even though I don't like drawing it this way, I'm going to draw it like this to match. Well, that's not it. Hold on.
His legs are cut off.
X equals
Yeah,
Y.
His arms are cut
I
off.
feel so small doing that. Even though
All right. Normally, a 45, 45, 90 is 1, 1, root 2.
That's what I remember.
Okay?
The legs are
So I need to associate things in one triangle with things in another.
I remember this. Similar. No.
Pretty
Yes.
much, yes.
Yes.
All right, so I'm going to do y over the square root of 21 equals, 1 over the square root of 2. Then I can cross multiply. Technically, I don't really need to fully cross multiply because I want y by itself. So I'm just going to multiply by the square root of 21. So y equals the square root of 21 over the square root of 2. Obviously, I can't leave it like that. So
That two's the
I'm going to multiply by the square root of 2 over the square root of 2. Okay, I need to rationalize. So that's going to give me the square root of 42 over 2. Now, in this particular case, x and y have to be equal, as was pointed out. So this is also equal to x. Okay? So they are both the square root of 42 over 2.
Can the square root of 42 be broken down?
No, because 6 and 7 and 3 and 2 is not together. Boom.
All right, now,
Yes, brother.
Boom.
I'm going to, again, I don't normally do this, but I'm going to do one so that we see it for practice. 19. My triangle disappeared.
I like these ones better because you don't have to write a lot more.
Oh, it's a 30, 60, 90.
30, 60, 90 triangle, which means that.
So
The leg
this is a
half the long
special-
leg. Wait,
So this is a 30, 60, 90. So compared to a regular one, again, I'm going to draw it the same way for comparison. What do we know about the side lengths of a 30, 60, 90?
the short leg is twice the long leg. No, yeah,
No, yeah.
no. The short leg is twice the long leg.
There's something
And the
with root
long
3 in
leg is
there.
something the square root of 3 is the
What are the other
hypotenuse.
numbers?
So it's like 2.
No, it's like the square root of
2 root 3.
yeah, 2 root of 3.
2.
I don't think so, Ryan.
2 square root of 3, right?
Man, y'all are bugging.
No.
Short leg equals
1,
twice the long.
2,
Long leg
root
equals
3.
2 the short
Oh,
leg.
okay.
Yeah, something like that.
No.
It's a 1, 2, root 3 triangle.
Oops, I wrote 20 instead of 30.
That makes sense.
Where did you get 30?
Bless you.
45, 45, 90 must have been ingrained a little more than
69.
30, 60, 90.
Hypotenuse equals half twice the.
All right, so I'm basically going to be doing the same thing, okay, as far as comparing. I just have to do two separate ones
Two white.
now. So I'm going to do 12 over y, or I could actually do y over 12. So y over 12 equals 2 over the square root of 3.
Oops, can't do that.
I'm going to multiply by 12. So y equals 24 over the square root of 3. And then, like you said, I can't do that. I got to multiply by root 3 over root 3
How did you do that?
and multiplied by 12.
So
Solving an equation.
Root 3.
Shepard, you need to lock it.
24 root 3 over 3, which reduces to
8. Show mine.
8 root 3. So y is 8 root 3. But now I've also got to find x. I can either do that by similar things, or I can know that x has to be half of y, because 2 to 1, half of that.
Which is
So x would be 8 root 3 over 2, which is 4 root 3. And there would be x.
I remember all this from geometry.
Good job.
But we had to do it like
I don't
a
even
roundabout
remember.
way, like using the cosine.
Yeah, we have to do it very difficult.
And I kind of liked it for some problems, but I didn't like it for other problems.
Yeah, well, you've learned it. Now I'm teaching you a shortcut. All right, next thing. Solve triangle ABC using the diagram and the given measurement. So they're going to give us angles and some side lengths, and we obviously know it's a right triangle. And then I'm going to find the other things. Okay, so they give us for all of these problems that our triangle looks like this. And that's important because your answer will be wrong if you draw it differently.
Gosh, diggity dang it.
Okay, remember, lowercase letters represent side lengths, uppercase represent angles.
Wait, I need to write this out. So, opposite hypotenuse, opposite adjacent hypotenuse. TOA is opposite adjacent.
Okay, 22. So obviously we know angle C is 90 degrees. So 22, they give us angle B is 53 degrees, and then side A is 12. So anytime I have a problem like this, I will go in and redraw the triangle filled out with this stuff where it's supposed to be.
Is it 12 inches?
Now, you will have this triangle for reference for you, okay, in the book. You don't need to rewrite this one every time. Just fill in the stuff that's missing. Okay, I already know that's 90. And then angle A up here, I don't know. Angle B, they told me, is 53, so I'm going to write in a 53 there. Side A goes down here. This is 12. So then I need side C and side B. So just like we do with when we're finding the 6 trig functions, we're basically going to set up a box like that and put all this stuff in there. I don't care if you write the side lengths first or the angles first. I usually do angles. So angle A, angle B, and angle C. Side A, side B, side C. All right, so side or angle C is 90 degrees. That's always and forever the case if we have a right triangle. B is 53 degrees.
37.
How'd you find that?
Because you added it to 180.
Because that has to equal 180.
There we go. So initially I was just writing in everything I know, but yes, I technically also know angle A because I know one other angle plus the right angle. So to find A, we would do 180 minus 90 minus 53, which as Ryan already found for us is 37 degrees. So if you want to write it into the triangle so that you can tell at the end that you found everything, you can. I don't care. Sometimes I write it in the triangle. Sometimes I just write it in the table. It's back and forth.
Yes.
However I'm feeling that day.
The cosine.
All right, now I need to find side B and side C. Okay? So I use trig functions to do this with. I will tell you, I would recommend you use as much given information as possible when finding this stuff. Because let's say you happen to subtract wrong and this really wasn't 37 degrees. If I use 37, I'm going on an assumption that that number is correct. Now, as far as angles go, if you subtract wrong, considering you have a calculator, something's wrong. But I try to use as much given information as possible, and this will really come into play when we get to 13.5 and 13.6. Okay, those two sections, you're really going to want to make sure you use as much given information as possible. So just make the habit now. So if I want to solve for side B, and I want to use given information, what trig function associates angle B and then something that has to do with side B and
Cosine of
side
B.
A?
Tangent
Cosine of B.
B.
Tangent.
Either.
I can't use,
'Cause
well, cosine, I will use cosine, but to find C. Right now I'm trying to find B. So for right now, tangent of this angle, so 53, equals opposite B over adjacent 12. And then all I have to do is multiply by 12. So 12 tangent of 53 equals B. Now, this would be a good time for us to pause and look at something on your calculator.
I told you I needed it.
Dang it.
Because you gotta do the numbers.
All right.
I hope I have this button on my calculator.
All right, so if you're using a graphing calculator, if you just have a scientific calculator, you don't really have to worry about this. But we have something which you haven't learned yet called radians, and then what we're using currently called degrees. Okay? My calculator is often back and forth between modes. Your calculator, though it is smart, doesn't know just off the bat what mode you want it in. So we need to make sure that everybody's is in their correct mode. If you have a siblings calculator, or you're borrowing one, theirs may be in the wrong mode. Okay? If you just got it fresh out of the box and you've never done anything like this with it, you probably are already in degree mode. So what we're going to do is we're going to hit mode up here at the top. And then you're going to go down to where right now for me you see radian is highlighted. Okay? Which is going to be a problem. Which is going to be a problem when I type in my answer. So don't do anything yet, just stay as you are.
Alright.
So look, I'm still in radian mode, I didn't change anything. So if I do 12 tangent of 53,
Yeah, I don't think that'll work.
I get negative 5.17. First of all, does that even make sense?
No.
Yeah.
No, why?
It's
'Cause it's
negative
not a
and
degree.
it's big. Like,
Why is
It's
negative?
it's negative and I can't have a negative side length. Okay, so that's one red flag that maybe something's wrong, but that doesn't always happen. Okay, radians don't mean my answer comes out negative. But back to mode.
I got 15.
Down here to radian. All right, my answer's wrong. All right, so if your calculator's not in degree mode, arrow over to degree and hit enter, and that one should now be highlighted.
Oh, it is.
Okay,
highlighted.
hit second mode, which quits and gets out of there. I'm going to retype this in degree mode. So 12 tangent of 53, and I get 15.9 degrees. Okay, one decimal place is fine. The book is using 2, but they don't specify. That's just how they gave their answer. So this is, I don't know why I said degrees. This is a side length. 15.9 is side B.
Bless you.
Thank you.
Now, earlier Zach said cosine to find side C, so we'll use that one. So cosine of 53 equals adjacent, which is 12, over hypotenuse C. Now, if I have this and I have this C on the bottom, I can just swap the cosine of 53 and C. Okay, they can just swap places. So I would have C equals 12 divided by the cosine of 53.
I remember this. So 12 divided.
And so C is 19.9.
That's what I got.
Me too.
So that's that side length there.
I didn't have to put it in yet.
All right, now that's technically all that's in this section. I typically show 1 or 2 more examples of this, but the bell's about to ring. Do we feel like we're gonna need to see another one of these, or we feel like we're okay?
I can see like one more.
Okay.
I can't take a test on it.
Is this one just like a 3, 4, 5 triangle, but like a little bit off? Like,
Copiosaurus?
So those are Pythagorean triples. So no, this is not. A Pythagorean triple has to be perfect numbers.
yeah, but it's like almost.
As soon as he
The-
got
the-
out.
the ang's like
Not
almost.
really.
Okay.
All right, I'm gonna go ahead and give you your problems, but you will have time tomorrow in class to do them. Well, I'll do one more example, probably just on the board tomorrow to start out. Just remind me if I forget, and then you'll have the rest of the time to work. As far as that goes. So we've got 3, 11, 13, 17, 23, and 27.
My shins are cold.
You should have done 19.
Have a great day.
Have a good day, man.